Instead of opening a bottle of wintergreen extract, let's build the same powerful scent from the ground up by synthesizing the molecule behind it, methyl salicylate. Here's the game plan. Start with salicylic acid, a solid, both with an acid group and a phenolic OH. Add methanol, a small alcohol that will become the methyl part of the molecule. Then bring in concentrated sulfuric acid as the catalyst that kicks the reaction into gear. The transformation is a Fischer esterification, a carboxylic acid plus an alcohol in the presence of a strong acid, in equilibrium with an ester and water. The job is to push that equilibrium towards the methyl salicylate and then separate and clean up the product. As you saw, I started with a 50 ml round bottom flask, and into it I added 5 grams of salicylic acid, and then I pour an excess of methanol. I used 20 ml for this reaction. And adding an excess of methanol does two jobs. It dissolves the salicylic acid and helps drive the equilibrium towards ester formation. Yeah, so this is me adding 2 ml of sulfuric acid, and as a rule of thumb, you should actually do this in a slow and controlled manner. So after that, I attached the reflux condenser to the raw and bottom flask and secured everything with clamps. If you want, you can place a drying tube of calcium chloride on the top of the condenser to help limit moisture entering the system. Yeah, and then I placed the flask in an oil bath and then gently heated it to around the boiling point of methanol, around 65 degrees. Then I refluxed the mixture for about an hour, and then over this time the esterification progresses towards the methyl salicylate. After the reflux period, remove the heat and allow the mixture to cool to room temperature. So as you can see here, I'm just carefully adding aqueous sodium hydroxide to the reaction mixture, but you can also use sodium carbonate or sodium bicarbonate. And this does two things. It neutralizes the sulfuric acid and any unreacted salicylic acid. So as I'm gradually adding more aqueous sodium hydroxide, let's talk about the overall mechanism for this Fischer esterification reaction. So the acid protonates the carbonyl oxygen of the carboxylic acid, making the carbon more electrophilic. And then our nucleophile, the methanol, then attacks the carbonyl carbon, forming a tetrahedral intermediate. After proton transfers and a loss of water, the ester methyl salicylate is formed. And then the catalyst is regenerated in this reaction. Yeah, so just as an aside, alternative strong acids can be used for this esterification. You can use like hydrochloric acid as a direct substitute, though it may require slightly longer reflux times or higher concentrations for comparable yields. So yeah, I'm just continuously adding more sodium hydroxide, and I'm monitoring the pH with pH paper, and the target should be around a pH of 8. Yeah, so I found these pH changes quite interesting. We start with almost this cloudy white mixture, and then the reaction turns to this almost pink color, and then clears up into this almost gold color. And obviously we can see the methyl salicylate, this sort of cloudy sort of oil droplets much more clearly. After reaching the proper pH, I transferred the mixture into the separatory funnel. Then I extracted the mixture with dichloromethane because that's going to be our organic solvent, and the methyl salicylate is going to migrate from the mixture into the dichloromethane. So isolating the organic layer and then evaporating dichloromethane yields the product, which is a clear and viscous oil. So once you've isolated your methyl salicylate, how do you prove it's the real deal? So I decided to use a 60 megahertz NMR spectrometer. Yeah, so in the proton NMR spectrum, it shows signals that match the structure of methyl salicylate. We observe a sharp singlet around 4 ppm that integrates to 3, which matches our methoxy group, and then another singlet around 11 ppm, which comes from the phenolic OH. And then in between those two signals, we see the aromatic protons. They usually come as sort of a complex multiplet around 7 to 8 ppm. But we could see with the integrations, those numbers below, that they integrate to 4 protons, which does match our structure. Thanks for watching to the end. The NMR peaks confirm pure methyl salicylate.